Let's meet Nathan again. He had a great party with his friends last Friday. The Cork app in his mobile enabled him to find out the favorite drink of his friends and a winery from which he bought the drink to give his friends a surprise. Due to some network issues, he was not able to connect his mobile to the internet. Still, he could view the details. How was this possible? Well, his app cached data from Twitter and Facebook and stored it in the local storage of the mobile. Let's now discuss how apps can cache data from external sites. With native application programming interfaces, APIs, you can store databases and cache large datasets without requiring the application to contact the server every time a user navigates to an existing page. The databases, caches, and datasets are stored in the local storage of the mobile device. The addition of local storage in HTML5 minimizes the wait time for a web page to load. Your goal is to use the local storage for accessing data. Your task is to cache the data from social networking sites in the mobile device storage. The prerequisite for your task is to know how to cache the locations and tweet using local storage. Before you start caching, you need to build elements. Building elements involves creating the MyStorage function that includes the functionality to store data in local storage. Then you need to cache geolocations, venues, and tweets. Finally, you need to save details in the Settings tab. Now, let's perform these activities.
In the previous session, you had learned how to create an HTML5 web application and connect it with the web API for, let's say, a remote social application. Now, what that basically does is that based on the user's inputs, you went ahead and searched the net and got the relevant data. Now, what happens if the user's internet connection is slow and laggy? It will directly impact your application's performance. Your application will appear to be laggy, it will appear to be sluggish and slow. So what do we do to enhance the performance, to enhance the experience that the user feels that this is faster? A simple solution around this is to actually cache the data that you have received so that you can display the data from a local store to the user while you go ahead and search the net for the latest updated one. This methodology requires you to save some data on your local storage. In this discussion, we are going to talk about how do we store that data in a local storage elements. Before you start caching, you need to build a function because we are going to reuse this code over and over again. I recommend we'll create it as a function. But before you start caching, you need to build a function that you can reference throughout this exercise to make interacting with local storage easier. So we are going to write a storage function called MyStorage, which includes all the functionality you will need to store the data locally. And then you can use this function every time you need to do this in your application. We start with creating a MyStorage function. In the index.html, copy and paste the contents as you can see here, the set function, the remove, the get, and the clear function. Now, while these functions may mimic the syntax of local storage.set.item and local storage get item, it is nice to incorporate these methods in a function. We call it the wrappers. Basically, the objective of this wrapper is the ability to do things before you actually call the final function. We will talk more about it in the subsequent videos. For the set method of MyStorage, you basically pass two variables, A and B. In this case, A represents the index or the key, and the B value actually represents the value. So we are giving them a key name pair value in this particular function. Now we go ahead and add the remove and get methods. These are very similar to the local storage method, add and remove. One of the long-standing problems that an app developers have faced with respect to caching geolocation and venues is that users will typically move their physical location. One of the simplest methods to update your information is to use something known as a watch position. Basically what this function does is that it keeps updating your location based on how the geolocation has changed for your mobile device. While this is simple, it causes a significant problem. It quickly drains out the batteries for your mobile phone, because what it is doing is that at every millisecond level, it goes ahead, checks the status of its position, recalibrates its position, and then reports it back. That's not an acceptable situation in the modern world. So the solution here is to keep track of not only the lat long of the user, but also to keep track of the last timestamp, so that when the user is once again requesting a refresh, you don't have to go and check the status at the device. What you can do is you can check if the current timestamp is not very old as compared to the timestamp of the last cache data, and if it is not, you would rather use the data from the storage and give the user that information rather than once again going and checking from the geolocation environment. So for doing this activity, we need to perform these steps as you have defined in the session guide. First of all, go ahead and make the changes of the success position function. Similarly, the on hash function where you get the get current position, add some code as defined in the session guides. Once you've done all those changes, as you can see in the video, you have done the following few changes. First, you've removed the logic that parses the points on the map and you've replaced it with a new function called parse map. You're checking to see here that the cache time of the local storage object is greater than 5 minutes. If it is, you will need a fresh pull. Otherwise, you're going to use the existing cache data to report to the user his current geolocation. If everything is okay, you're going to pass the cached venue object or the new venue object to the parse map function. In addition, what we have done in order to make our application a bit more UI specific, we have added another function called resize. This will resize the map in accordance with your current screen size accordingly, so that the image of the map is not cut from the sides or overflows in your screen. Now that we have a great function to use the cache data using local storage, we can do the same thing for Twitter in a Cox application. What we basically need to do is to change the Foursquare parse application that we had used earlier to parse the details of the vine. We are going to create another function called parse tweets for the Cork application and make the changes as defined in the session guide. Basically, the changes that we are going to do are two. First, instead of taking the two variables, we are also going to take wine_id as one of the variable. This is the variable which we will use to index our local storage. Remember, the local storage has also to be referenced, and we chose wine_id as the reference index for the same. Now we go ahead and change the function that actually pulls in the wine detail. Basically, what we have done here is not only to pull the information about the wine details, but also the timestamp at which it is being used. Therefore, just like the geocaching code, when the user asks for the data, we can double check whether this particular data is either stored already in a cache and the time duration is less than what we have set for. If so, we will give the data straight from the local storage. If not, we will go back once again and search the internet for this particular data. So far, we have seen how to take care of local storage for data that is coming from either a web API, that's a social network site, or from the basis of the local hardware configuration, which goes and gives you the local lat long from the internet site. Like we have saved these data, we can also save the settings data. It is quite possible that you may want your users to be able to save or store some data, which is the user configuration data. In this session, we will talk exactly about that. To achieve this, we will first build out a settings tab. You need to add markup similar to the HTML you have used to build the other pages within the jQuery mobile. So you need to add the index.html, the code that has been written in this session guide for this particular exercise. You will find it on page number 318. Basically, the first section simply adds a form in your page containing an input box where the user will type in his username, and that's what you will save. The function at this point of time is fairly simple. It just uses the hide and show methods to toggle the results message from being shown to the user. As you can see, once the changes have been done, After this, close your browser and reopen it. Go ahead, navigate to the settings page. You should see the name that you had entered earlier, stored and displayed to you from the local setting. Alright, so we have learned so far how to take care of a local storage. We learned how to interconnect with the social network sites, and we learned how to put the data into database. With this in place, the last stage is to figure out how to search from our information. We now basically want to search and display the results of the elements. Once again, as you did with the settings tab, go ahead and create a basic template for the page. You need to create something immediately before the settings page so that the users can view the search page as shown in the session guide section. Once you have done this, go ahead, save the index.html file, navigate to the search page as you can see here, and enter the last line that you entered probably. Based on this, as you can see, you're going to get the result of Paul Roger in our case. Clicking on this should give you a detailed page on the next section. What we did here was, this is a function which is very similar to grab activity. However, because you want this to be a search query, you're using a DB query so that it can search not only in the name but also on the wine ID and the wine name and the wine details. Based on this, the elements were displayed. In the session guide, you will also find a little bit of user interface cosmetic changes in terms of the UI and the UL. Please incorporate that if on your page it appears slightly misfigured. But what we were able to do here was, we used a structured query language SQL technique called inner join, which allows us to take two tables in your database schema and join them on a common field. In this case, the common field was wine ID, wines and activity tables. By doing this, we are getting information about both the activities and the wine by executing the search queries.
Having cached data, you can enable users to search the Activity tab for specific information with the help of the Search tab. This will display the data when a user searches for it. This brings us to the end of this session, in which we learned how to connect HTML5 applications with social media. For more details on these elements, please refer to your study material.